Hey, it's Jack with the New River Farm Sawmill. Hey, so wood shrinkage, I mentioned it before, it generally isn't a mystery, and if you know kind of what the wood's going to do or how it's going to act, that's going to be super helpful for you when you go to use the wood. So I have this handy little piece of white oak right here that we're going to use to talk about basically the three different directions that wood can shrink. So once upon a time this was a tree. It grew like this, right? This is the center of the tree. Let me use my pointer. This was the center. This is called the pith, and these are the rings. So the three ways that wood can shrink would be longitudinally, which is along the grain. So if you had an 8-foot board, we're talking about the 8-foot length. And then you have your tangential, which is along the rings. And then you have your radial, which is basically a radius of this circle. So if we looked at this as a circle, I know this is a square, but when it grew as a tree it was a circle. This was the center. These are the growth rings. These are the rays that go from the center out to the sapwood. These are the pores. They're what looks like little holes when you look at the end of a board. And then in between each pore ring is wood fiber. Wood fiber is the dense part of wood that makes up the structure. It's the cell walls. So basically wood mainly shrinks because of it losing water and its pore channels. So when they dry, we're pulling water out of those cells, or nature's pulling water out of those cells. Just like a sponge, when you squeeze a sponge, the water releases and now it becomes smaller. The same thing happens when you release the water inside of those rings. There's more pores tangentially, so this is tangential, which is along the circle or along the growth ring. There is more water and moisture tangentially in those pores than there is radial. Radial is from the word radius, which is from the center to the outside. So if you look at this, everywhere there's a line of pores, it's broken up by a ring of fibers. The fibers don't really shrink because they're pretty much already hardened. It's mainly just accepting water in the pores and losing water in the pores. So in general, wood almost shrinks doubly this direction, called tangentially, which is along the rings, as it does radially, this way, which is across the rings. So now that you know what parts mainly cause the shrinkage, we can deduce how the wood's going to shrink. So longitudinally, the wood is not going to shrink almost at all. It will be almost completely unnoticeable. You know, in a 10-foot board you might lose 1/8 of an inch or something. It's basically negligible. The reason is those fibers that I talked about extend from end to end. So they go from one end of the tree to the other end of the tree, and they're not broken by any of those pores. So that's why it does not really shrink longitudinally. Now you can already see this right here, let's get it focused in, is splitting radially. So you see that all the time in firewood, for example, and the reason is these pores are trying to contract. So they're doing this number, they're trying to contract around, they're shrinking in a circle, and so this wood, the further away from that center you get, the more this wants to crack. So you can see the crack's not very large down here because the circle is not very big that's trying to shrink. When you make your way all the way to the edge here, your circle's a lot bigger all of those pores along that circle are trying to contract. So this is going to give, and it's going to break right near one of those rays. Hey, thanks again for watching. I hope that video is helpful to the woodworker out there. Again, if you need a source for your retail lumber needs, we're in the New River Gorge region. We stock a lot of hardwoods and do custom stuff to order. We mill, dry, and plane your wood for you. So come see us, visit our store, or contact us online. Thanks.